Hello all. So in general, when you're working with machine learning, especially when you're working with algorithms like linear regression or logistic regression or SVM, you need to find the minimum of a function, right? For example, if you take a linear regression example, if you take a linear regression, you need to find the minimum of, right? You need to minimize the errors in the linear regression, right? If you take a linear regression algorithm, you need to minimize the errors. So you need to minimize basically the MSE value, that is this particular equation, that is summation of I is equal to 1 to n, y actual minus y pred whole square divided by n. This is this is nothing but your MSE value, right? The mean squared error, we call it as mean squared error. So the main goal of linear regression is to minimize this particular error value, right? We will be having an equation like y is equal to mx plus c to fit a best fit line, and the line which is minimizing this particular mean squared deviation, that is nothing but your best fit line, right? But in order to minimize this particular equation, okay, which technique we use? We cannot randomly move your line, right? If you randomly go on moving, it will take years to find out the best fit line, right? So which technique you will be using in order to find out a best fit line? In general, the best technique is something called as gradient descent, right? There is a technique called as gradient descent, and this particular technique will be helpful to find out the minimum of this particular function. But the gradient descent algorithm works under which principle, or how gradient descent works? So basically, gradient descent works with help of derivatives, right? We know that gradient descent will work with help of derivatives. So which is a very most important concept. So in this video, we will try to understand how exactly this differentiation or derivative works. Okay, why we use derivative, how we can use the power of derivative to apply gradient descent and minimize this particular error and ultimately achieve the best fit line in linear regression, or a best separator in logistic regression, or a best separator in SVM, or any other algorithms where you use gradient descent. Okay, so let's start with understanding what exactly is derivative. But before understanding derivative, let's understand few things, right? Let's assume a simple example. Let's assume you are having a graph, something like this. Let's assume two graphs, okay? And here I'm trying to draw a line, okay? I'm trying to draw lines in this two graph, or a random line, okay? Just a random line. This is one particular line, right? And this is one particular line in this particular two graphs, right? Let's assume I call it as this line as pi 1, and I'll call this as pi 2. Okay. So if we just look at this both lines, what is the main difference you observe in this particular line? You can see this particular line is less steeper, right? It is less steeper, whereas it is slightly more steeper, right? When I mean by steep, what do you mean by that, right? The slope, right? The main thing is the slope. The slope is I for this particular line, whereas for this particular line is slightly less. Will you agree? Yes. Right. Means more clearly, for example, there is a person standing here. Let's assume if a person standing here, if another person is standing here, if this particular person want to move from this point to this point, it will be easy for this particular move, for a person to move from this point to this point. Whereas for this particular person will slightly have to work hard to move to this particular position because it is more steeper, right? That is the reason climbing a steeper mountain is somewhat difficult, right? Chalo. So now the main point here is, the main point what I want to convey here is, if I want to mathematically represent this particular steepening, that is slope, how do I represent this mathematically? If I want to find out a slope of a line, generally a equation of line is given by a equation that is y is equal to mx plus c. Okay, this is a general equation of a line, right? This is the general equation of a line where you are trying to find out the relationship between y and x, and let's assume this is your x and this is your y and this is your line, right? If I want to find out a slope of this line, simply we can find out by a formula, that is y2 minus y1 by x2 minus x1. This is a formula which we have learned long back ago. But the point is, what is the main idea behind this particular formula? So generally, for example, let's assume we'll take 2 points P1 and P2 in your line. Okay, where P1 is changing from one point to other point. So what you're trying to do in slope, you're trying to find out what is the change in x, what is the change in y with respect to change in x, especially 1 unit change in x. That is what exactly slope is. Means what you're trying to do, for example, here, if I take these 2 points and make this as x1 and make this as x2, and the respective points will become your y2 and this point will become y1, right? So I can draw exactly a kind of a right angle triangle here, right? If you just see here, I can draw a small right angle triangle. Just a second. Yeah, I can draw a small right angle triangle like this, something like this. So the main point is you are trying to find out the slope. What will be the slope? The slope is nothing but your y2 minus y1, that is this particular distance, right? And this particular distance. You are just finding out the ratio of this, right? That is what your slope is. And what is the slope indicating? What is exactly this slope indicating of a line? What is the slope of a line? It is nothing but change in x with respective change in y, or we can say like this: change in y, change in y, change in y with respective unit change in x, unit change in x. So when I say unit change in x, what do I mean by that? Means if your y is changing from, maybe if your x is changing from 1 to 2, 1 to 2, there's a unit change, let's assume. How exactly your y is changing? That is what the unit change in x, and that is what you're trying to find out in the slope of a line in general mathematics, right? And we already know about the slope of the line. It's nothing but y2 minus y1 by x2 minus x1, and this is how you'll be finding out. And for example, if I want to talk in terms of angle, if you just look at this particular part of a simple right angle triangle, you can see clearly that there is an angle here, right? There is an angle between these two things, and we call it as theta. So the slope of a line can also be represented by something called as tan theta, right? It can, if you want to represent this particular slope in an angle, it can also represent by tan theta. So tan theta will be the exactly same as y2 minus y1 by x2 minus x1, right? Okay. So we understood regarding the line. That is, if the equation of a, if equation is something like this, if your equation is something like this, then your simple slope would be, your slope would be y2 minus y1 by x2 minus x1, right? And you would then, and you are trying to find a line. But what if your equation is something like this? Y is equal to x square. What if your equation is something like this? A different equation. Don't worry where exactly we are using this equation. We'll try to understand this soon when we are discuss about this gradient. Okay. Let's assume we are trying to find out this equation. We have this equation. Okay. Now, if I just take a graph of this particular equation, if I draw the graph of this particular equation, it will be something like this. It is kind of a parabolic shape, right? It's kind of a parabolic shape. Your graph of equation will be something like this. Now, you can see clearly that this particular line, or this particular this particular parabolic is no longer a line. I mean, this is no longer a line, right? This is no longer looking like a line. Now, in this case, if I want to find out a slope, if I want to find out a slope of this particular curve, it's looking like a curve now. If I want to find out a slope of this particular curve, how do I find out a slope? That's the main point, right? So basically you can see that, okay, let me take a simple curve to make it simplified. Let me take a simple curve. Okay. For example, if you have a curve like this, like a half of this particular curve, I've taken a half of this particular curve. If I want to find out a slope of this particular curve, how do I find out a slope of this particular curve? Generally, if you just look at this particular curve, you can see that the slope is actually changing here every time, right? For a line, the slope is equal at everywhere. Generally, for this particular line, the slope is equal at everywhere. But for a slope, you can see the slope is always changing. The slope is not equal everywhere. And moreover, if you just go on to the top, the slope goes on becoming more steeper, right? The curve becomes more steeper, right? Then means, the curve is, the slope is increasing when you go to the top. Will you agree? Yes. And if you just come to the bottom, your slope is decreasing. Now, if I want to find out a slope of this particular line, I want to take a small example. Okay, I want to take a small example. First thing, let me ask a question here. Is your earth round or flat? Obviously, no. Obviously, we say that earth is round, right? Earth is round. Just assume this you're representing earth. Okay. Now, the point is, when you are saying earth is out around, but when you just look at your surroundings, you can see that it is like a flat shape. Why? Because if I just closely observe this particular curve or this particular circle, we can clearly see that at this particular point, it is like a flat shaped, right? It is like a flat shaped. So if I just draw a line here, I can get a slope of this particular line, right? And this is called as tangent line, basically. This is called as tangent line. So the main point I want to convey here is, when you have a curve, you cannot get an entire slope of the curve. Okay, you cannot get the entire slope of the curve, but you can get the slope at a particular point, maybe P. If you are here, you can get a slope at that particular point P. But how do I get? By approximating the line here, because we know how to calculate a slope of a line, right? So we can approximate a line here, right? So what you are doing, like how you are approximating a line here, you are trying to approximate a line here in this particular point, and you're calculating a slope here, and this is called as basically a tangent line. This is basically called as a tangent line. Okay, but the point is, how do you find out the slope of this particular point? And moreover, guys, the slope at this particular point, as you're trying to find out a slope of that particular point at a particular point, this is called as instantaneous rate of change. See, here ultimately in this case, you're trying to find out the rate of change of y with respect to change in x, unit change in x, right? You're trying to find out the rate of change. But here you're working with something called as curves, right? So when you're working with curves, you should find out something called as instantaneous rate of change. Instantaneous rate of change. So you are finding something called as instantaneous rate of change. Okay. But how do you find out? That is nothing but your slope. That is given by, for example, this is your y, right? And this is your x. Okay. Let's assume. How do you find out? So we clearly know that general slope is identified by something called as change in, what is that? Change in x, or we can say your change in y with respect to change in x, right? This delta y is identified as change in y, and delta x is identified as change in x. Okay, cool. But how do I find out the a slope of this particular point? So in order to find out a slope of a curve, the instantaneous slope of a differentiation of a tangent line, you can use this particular equation. That is nothing but you'll be using something called as differentiation. That is dy by dx. That is nothing but your change in y with respect to change in x. Change in y with respect to change in x. Okay. So let me take an example here to make you understand. As we are working with an equation called as y is equal to x square, if I substitute here, what happens? It will be something like this, right? What happens here if I substitute x square here? Everyone know, I guess, if you have learned about differentiation in your schooling, you might know that this particular differentiation leads to something called as 2x. But why we are getting 2x here? Why dou x square by dou x is 2x? What is the reason behind this? Let's understand this today, right? For example, let's take the same example here. Let's assume here you have a function here. This is the x square function. Generally, this is your x square function. This is your y, and this is your x. Now I want to find out at this particular point, I want to find out a slope of this particular curve. Okay, slope of this particular curve. Now, the main idea here is when you want to find out a slope of this particular curve, the slope formula, the slope formula, what is that? Y2 minus y1 by x2 minus x1. This is a general slope formula, right? Now, let's assume this is at this particular point, it is called as x, okay? So, let's assume at this particular point, okay, I'll call it as P1 to make it simple. I'll call it as P1. And let's assume this is P2, okay? This is called as P2, maybe something like that, okay? Now, your P1 at this particular point would be what? If it is x, then what would be your y value? Obviously, x square, because we know this is the equation of this particular curve is nothing but x square equation, right? So at this particular point, it would be x, your x would be, if it is x, then it would be, y would be x square, right? These are my 2 points. Then at point 2, you're trying to decrease your x value, right? Means just you're changing your x value by delta x. And this is your line approximation, let's assume. This is your tangent line approximation. And you are trying to change your x value. Means you're trying to just change your x value. Let's assume your x value is 2. You're just trying to change, doing a small change, very, very small change, maybe around 0.0001. I'll call it as delta x. Delta x means change in x. Means you're trying to decrease your value by delta x, right? You're trying to decrease your value, your x value by delta x. Then automatically your y value will be decreased by what? Obviously x minus delta x square, right? So what you are doing, this delta x is nothing but 0.1. Means if your value is 2, then your final change will be your 2 minus 0.0001. So you can just calculate how much it is, right? Very, very small change, right? So what I'm doing, I'm calling it as 0.2. This 0.2 will be, this 0.2, whatever I'm showing in this particular graph, this particular 0.2 will be the point which is very, very small in nature. Okay, very, very, very small in nature. Okay, cool. This is my curve, let us assume. Okay. Yes. So your this P2 is nothing but very small change, okay. Now, if I want to find out the slope of this particular 2 points, I mean, slope is nothing but what, how your x value is changing with respect to y, right? How your y value is changing with respect to x, whatever. So now, if I want to do that, I can just do a simple like P2 minus P1, right? So I can do like this. So x minus delta x minus, sorry, let's start with y. This is your y, right? Let's start with y. So x minus delta x whole square minus x square, right, divided by your x minus delta x minus x, right, obviously. So you can see here this x and this x will be cancelled, and this would be what? It is nothing but a minus b, right? So we can say like this, x square plus delta x square minus 2 into x into delta x, right? Because it's a minus b whole square minus x square divided by your minus delta x. So if I just take this x square common, if I take this particular delta x common from this particular two terms, and you can see here this x square will be cancelled, and I'll take delta x common from this. So delta x will become delta x minus 2x divided by minus delta x, right? And obviously I want to apply minus here, so I'll just multiply by minus. Then what happens? Your delta x plus 2x divided by minus delta x. Okay, I'm just taking this minus outside. So obviously delta x and delta x will be cancelled, right? And obviously you'll be left over with delta x plus 2x, right? And we know that delta x is very, 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 very small value, almost close to 0. We have taken already that delta x is very, very small value, 0.0001, right? So finally, if we just look at the final output, the slope of this is 2x. So this is how we can prove this point. So already we know from our differentiation that dou x square by dou x is nothing but 2x. But with help of our simple understanding of how this slope point means, you are trying to find out from this point to this point, if your value changes, what is your value. So according to our differentiation, at any point of the curve, if you want to find out the slope, it is 2x. 2x. This is what your differentiation is. Dou x, sorry, dou y by dou x. Right? This is how you will be identifying the your slope of a curve. So mainly, what is the main use of differentiation? What is the main use of derivative? What is the main use of derivative? First thing is to find the slope of a curve, right? But there is also the second use, the major use, which we use in gradient descent for actually implementing the gradient descent. What is that? See, if I just take an example here, let's assume your graph, again the same example of a parabola, right? If I take a parabola example, and if I just look at this particular point, will you agree that this particular point is nothing but your minimum point in the parabola? Yes, right? This is a minimum of the function. And what would be the slope at this particular point? For example, if I draw a line here, and if I want to find out the slope, clearly you can see that if I change my x value here from, for example, this is your x changing to delta x, your y is exactly same here. So obviously your y2 minus y1 by x2 minus x1 would be 0. Why? Because when your x is changing from x to delta x, your y is not changing. So the slope of this particular point, that minimum point, wherever your function is, the slope of this particular point is 0. Means more clearly, the slope of tangent is 0 here. The slope of tangent is 0 at this particular point, right? So when I say slope of tangent is 0, your derivative of this particular function would be 0 at this particular point, right? Means here derivative can also be used to find out the minimum or maximum of a function. Why I am saying maximum? Because see, wherever your slope is 0, we can say it is a minimum of a function. The same way, if I take, let's assume my graph is something like this. Let's assume my graph, my equation is something like this. Here also, obviously, this is nothing but your, again the same way, your dy by dx would be 0, right? There is no slope here, and this is nothing but your maximum point, right? This is your maximum point. So we can now clearly say that from these two particular function, here you can see that wherever your slope is 0, that's nothing but your minimum point, and wherever your slope is 0, that is also a maximum point in this particular graph. And you might also have a function like this where you have multiple minimums also. For example, you have some multiple minimums and maximums. So in this also, wherever you have minimum and maximum, that becomes your what we call your wherever your minimum maximum, that wherever there is, that is nothing but differentiation is 0. Your slope of tangent is 0. But yeah, so the main point here is, along with finding out the slope of a curve, however we know how to find out a slope of a curve right now, along with that, you're able to find out where exactly your minimum and maximum of this particular equation lies. So wherever your slope of the tangent is 0, wherever this particular slope is 0, there exactly it lies a minimum point. And for example, this particular function, in this particular parabolic function, that is this one, you have only minimum value, they don't have maximum in this case. So this is your minimum wherever your dy by dx is equal to 0. So exactly this particular concept we will be using in gradient descent in order to actually, of course, both will be using to find out the slope of the curve, and exactly this particular concept will be using to find out the minimum, right? So it is used to identify the minimum, right? It is used to identify the minimum or maximum of a equation. These are the main two reasons why we use derivative or differentiation for in general, right? So in your schooling also, you might study of how to minimize a function using a gradient, using a differentiation, or how to maximize the function. But you don't know why we are doing that one. But now you know that For example, if you're working with linear regression, let's assume the main idea of linear regression is what? To minimize this particular equation, right? That is y, that is nothing but your MSE, summation of I is equal to 1 to n yi, that is your y pred minus y actual, or y actual minus y pred whole square divided by n. This was your MSE, and this particular MSE you want to minimize this. So if you want to minimize this, you need to use something called as gradient descent. Okay, and you can see it is looking like same thing like a x square function, right? It is looking like an x square function. So this is how the derivative works, and this is how we can use for derivative. So the main conclusion of this particular video is the main use of derivative is to find the slope of a curve, at given point, right, p, and we can find the minimum and maximum of an equation. So wherever your slope, whichever point where your slope is zero, slope of tangent is zero, or your dou y by dou x is zero, that becomes your minimum or maximum point of that particular equation. Okay. So these particular two concepts we'll be using in order to actually implement something called as gradient descent. Okay. So I hope you got this particular point, how derivatives work, how exactly the power of derivatives is. So in the next video, we'll try to understand how to use these particular derivatives in order to solve the gradient descent equation, right? In next session, we'll be taking the example of linear regression equation, that is your error of linear regression, and we'll try to solve that particular linear regression by using the differentiation concept, whatever we learned right now. Okay. So I hope you like this particular video. So if you liked it, please comment, please like, and share this video. Okay. Thank you guys.